So separation of variables is a method to handle probably the simplest kind of differential equations. Differential equations are equations that involve your variables. In this case, we're looking at x and y and a derivative, right? A dy dx term. And it doesn't have to be dy dx. It could be like d v dt equals something in terms of v and t. But the general idea is this, that you're trying to solve for y, right? That would be the solution of differential equations, and you're going to solve for y by eventually integrating both sides. But in order to do this, you have to, the reason it's called separation of variables is you're trying to get all of your x terms on one side with the dx and all the y terms on the other with the dy. And this is the biggest jump that I had to make when I was taking calculus, is that dy dx is not just y prime or f prime of x like the other ways that they use notation to represent the first derivative. It actually is two separate pieces. Like you can take the dy and the dx separately, and they are representing basically the change in y, like a very small change in y and a very small change in x, right? And so the first thing that you're going to do here is multiply both sides by y, right? So you get y dy over dx equals x plus 1, right? And then we're going to multiply both sides by dx, right? And this accomplishes what we were setting out to do, right? That we wanted to get, right? We wanted to get all the x terms on the one side, right, which we have on the right side, and all the y terms on the other, which we have on the left side, right? So this is a really critical step, right? Because now, with any equation, you can do whatever you do to one side of the equation, you must do to the other side of the equation. And what we're going to do here is set it up as the integral of y dy, right? So the operation that we're choosing to do is the integration of both sides, and I'm going to integrate this on this side. And here we have two indefinite integrals which you can calculate separately. The left side becomes y squared over 2, right? Normally you have a plus c, but when you have integration on both sides, you can just combine them into one. On the right side, you get x squared over 2 plus x, right? And on this side, we'll include the plus c, because remember, the separation of variables, you're solving for y, so we're trying to isolate y. We would take y squared equals x squared plus 2x plus c. Sometimes people question, like, why isn't c 2c? Well, it could be 2c, but since c isn't specified yet, we can just leave it like this. And finally, we would get the answer, right? The square root of the right side, right? X squared plus 2x plus c. And if you're given initial conditions, then you can go back and solve for c. Like if they said, like, y equals 3 when x is equal to 0, then you can say 0 plus c, right, square rooted should equal 3, so then c would equal 9, but that's just an example, and that's a quick example of separation of variables.